So we have one more student, Nandagovind. So congratulations qualifying RMO. So how long has your journey been? When did you start preparing?
Actually, my journey has been rather recent. I started my general preparations this February. So
Okay.
I've spent roughly about 10 months, 10, 11 months almost on Olympiad preparation. I did have previous experience with the computers, Olympiad informatics. So I was familiar with the basic ideas of combinatorics. And I followed strongly onto that. Combinatorics turned out to be my strongest subject. Majority of my marks came in IOQM in combinatorics. By the time it was RMO, I studied up a lot more of number theory and algebra theory. So I was able to quickly grasp, like the first problem ended up, as Aharashi mentioned, it was rather easy. So I got a 16 in that. And also due to my strengths in combinatorics, problem 6, I got a 15. So both of those already put me above the cutoff. Then it was just problem 3 was a lengthy bash. It just ended up being like that. My preparation mainly focused on combinatorics. I was hoping for a more combinatorics focused paper for RMO, seeing how the recent trend had been towards combinatorics. Didn't turn out that way, but I was happy with how the exam in general went. I find myself weaker in geometry. So my preparation has focused mainly on focus on your strong subjects, because if the trend follows, which is that really hard papers that test your ability as a solver, you need to solve at most 2 questions and you're through. So even if you're scoring like 14 or 15, as long as you get that in 2 problems, you'd clear the cutoff. For example, INMO cutoff last year for 11th was 19 marks, which is
Exactly.
just above 1 problem. So
Exactly.
yeah, I focused on that. Focus on one subject, 2 subjects, so that whatever questions come from those 2 subjects, you ensure you score a 14 or a 15.
We can be safe
So
enough. Correct. See how math problems work. If there is a problem, you just hit it with some ideas. Might be that is the breaking point of that problem. Maybe that is where the problem is built on. Might be it is not the case. Then what you do? You take a different direction and hit again the problem. So you keep on hitting the problems. Sometime it will not break through, and sometime it will break through. So what I suggest is maybe you can take some time, let's say 1 to 1.5 hours initially, and after that, even if you're not getting, try to give you some time. Maybe even it could be like 2 hours, or even 1 day or 2 day, or even 1 week. That's fine. And again try to hit at the problem in a very different angle that you would have not even thought about. So this is how knowledge expands. This is how your freedom to think expands the knowledge of mathematics. That's how it works. And again, sometimes again that might not work because your way of thinking might be very different. So that might not match up with the fundamentals of that problem. So in that case, you can take some hints, 1 or 2 hints, and then again try out that problem. Yes, Nandagovind, please go ahead.
So, for what I usually faced in such manners, one of the first things that I remind myself is a problem doesn't usually have a single solution. So, I struggle a lot with synthetic geometry, as I mentioned, but projective and bashing, both of these I am fairly good at. And a lot of the problems that involve synthetic geometry do end up succumbing to some projective geometries, maybe an inversion, or maybe it's just a complex bash. For example, those of you solved P4, that was a very elegant coordinate bash solution, about 3 or 4 lines. So when you remember that there isn't a single path forward, you actually open your mind to a lot more different things. So maybe instead of wondering how things look, maybe think if there's a specific point that you could invert about that makes things easier. Or like take a moment, process how this entire thing, how the entire problem looks, and think if you could maybe express that if there's a single circle as some sort of complex variant. Or maybe you might want to express it as in terms of coordinates, wherein you manage to write out the coordinates, manage to point hunt, if you would say so. And meanwhile, in case of the other end, combinatorics, for example, there are still a lot of different avenues. A problem could be solved using graph theory. One example I'd take for this is 2022 C1. Those of you are familiar, the problem statement basically goes like this. You're given an infinite set S that consists of certain numbers, positive integers, such that there exist A and B and C and D, such that GCD of AB is not equal to GCD of CD. And you're asked to find three numbers, X, Y, and Z, such that GCD of XY is equal to GCD of YZ, which is not equal to GCD of X and Z. Now, this seems like a very standard number theory problem. There is an elegant graph theory solution to this that involves a bit of coloring. When you realize that a problem is not limited to a single aspect, you can't even call some problems number theory or combinatorics strictly. Some problems involve geometry and number theory. Some problems involve geometry and combinatorics. There's all sorts of spectrums, all sorts of ways you could look at a problem. Maybe the method you're trying doesn't even work. So it's just about spending more time, persevering. I'd say you don't have to give up on a problem once you're done or you spent an hour on it. Maybe leave that problem on the back burner, try it a day or two later. Maybe some new ideas strike.
Very good. So uh, that's a very good point that should be mentioned in this place. So the thing is, if you just have the mindset that I'm just going to solve this problem and write the solution and go to the next problem. So that kind of mindset will make you to just think in a standard way that you are being taught about. But what if you think like this? Okay, I'll just try to understand what is being asked and just take a walk and think about what I can do about it. If there is some way, try to model it in some other way so that you can think about the problem just using your without just pen and paper. You can model that question. So once the modeling is done, you can write down like what you could do on it. So I would say that until you reach the stage of modeling a problem, you should have a very broad mind. Your mindset should not be oriented to solve the problem and go to the next problem. Your mind should be oriented in a way to just to think about the problem. No other thought. Even in the exams, I think this would be the best thing that you can do.